Earth has a problem nobody talks about. It's not too hot. It's not too cold. It's not radiation or asteroids or some distant cosmic threat. Earth's biggest problem is that it never stops changing. Every single day, the ground beneath you is moving toward winter, or away from it toward drought, or away from it toward storms you can't predict more than a week in advance. You call this normal. You call this home. But what if the perfect planet for life isn't one that changes constantly? What if it's one where the sun never moves at all? Picture a world locked in place, frozen not in temperature, but in time. One side staring directly into its star forever, the other side facing the black depths of space forever. No sunrise, no sunset, no seasons, just two eternal halves of a single planet fire on one side, ice on the other. Your first instinct is probably that this sounds like a nightmare, a planet too extreme to ever support anything alive. And for a long time, scientists agreed with you. But what if that instinct is wrong? What if the most stable, most productive, most quietly perfect planet in the galaxy isn't spinning through seasons like Earth does, but standing perfectly, permanently still? Let's talk about what a tidally locked planet actually is. Because the concept is simpler than it sounds. You already know an example. Look up at the moon. It always shows you the same face. You've never seen the far side with your own eyes, not because it doesn't exist, but because the moon is tidally locked to Earth, its rotation perfectly synced to its orbit. Now imagine that same effect, but on a planet locked to its star instead of its moon. One hemisphere bathed in endless daylight, the opposite hemisphere locked in endless night. No rotation relative to the star at all. This isn't some rare cosmic accident either. Around small dim stars called red dwarfs, the habitable zone, the region where temperatures allow liquid water, sits incredibly close to the star. And when a planet orbits that close, gravity grabs hold of its rotation and locks it in place the same way Earth's gravity locked the moon. Red dwarfs are also by a massive margin the most common type of star in the entire galaxy, which means tidally locked planets aren't some bizarre exception in the universe. They might actually be the rule. For decades, the scientific assumption was brutal. The day side would be scorched into a lifeless wasteland, water boiling away under a star that never sets. The night side would be the opposite extreme, a frozen tomb so cold the atmosphere itself would freeze solid and snow out of the sky collapsing onto the surface as ice. Picture standing on that night side and the very air you breathe slowly turning to frost at your feet. That was the prediction. A planet split between fire and a frozen grave with nothing habitable in between. Case closed. Tidally locked worlds were written off as dead on arrival, but modern climate models changed everything. And the part they got wrong wasn't the day side. It wasn't the night side either. It was the assumption that those two sides would simply stay separated, fire, here ice there, no communication between them. Because a planet isn't a static object, it has an atmosphere, it has oceans. And both of those things move. So what if the dangerous part of this planet was never the burning side or the frozen side at all? To understand why Earth might actually be the less stable option here, you need to see what Earth is really dealing with, hidden behind the comfort of your daily routine. Earth's axis is tilted, which means every single year, entire hemispheres swing from abundance into scarcity and back again. You call it autumn? You call it winter? But underneath those gentle names is a brutal cycle. Plants die back. Food sources vanish. Animals migrate thousands of kilometers or go dormant just to survive months of cold and darkness. Every single year, this cycle repeats, and every single year, it pushes species to their absolute limits. Some don't make it. Earth's fossil record is a graveyard of organisms that simply couldn't keep up with the changing rhythm of their own planet. Now, stack ice, ages on top of that. Multiple times in Earth's history, the climate has swung so violently that glaciers crept down from the poles and swallowed entire continents, wiping out ecosystems that had taken millions of years to build. Then it swung back the other way, flooding coastlines as ice melted and seas rose. Earth doesn't just have seasons, it has mega seasons, climate cycles spanning tens of thousands of years, layered on top of the yearly chaos you already lived through. Your entire civilization, every crop you've ever eaten, every city you've ever lived in, exists inside one narrow, temporary calm between climate catastrophes. And it gets more fragile than that. Earth's agriculture, the entire foundation that lets 8 billion people exist, depends on predictable seasons that are becoming less predictable every decade. A single unexpected drought can collapse harvests across an entire region. A single unusually cold spring can wipe out fruit crops before they even form. Civilizations have collapsed throughout history because the weather simply stopped cooperating with their farming calendars. Earth's instability isn't a minor inconvenience, it has ended empires. Now picture the tidally locked alternative. No axial tilt cycle, because there's no rotation relative to the star to create one. No seasons, because the amount of sunlight hitting any given point on the planet never changes. Not in a day, not in a year, not in 10,000 years. No springtime gamble, no winter to prepare for, no autumn die-off. Whatever climate exists at a given location on this planet is the climate that has always existed there, and the climate that will always exist there. While Earth's species spend enormous amounts of evolutionary energy just adapting to constant change, life on a tidally locked world could pour all of that energy into something else entirely. Specialization, complexity, growth. But none of these are even the real advantage. They're just the beginning. Consider energy. On Earth, every living thing that depends on photosynthesis is interrupted every single night, sometimes for 16 hours straight near the poles. Plants stop producing, ecosystems pause, energy collection literally halts for half of every single day. Now picture the day side of a tidally locked planet. The star never sets. Photosynthesis doesn't pause for a single second, not for a night, not for a season, not ever. The energy input into this hemisphere's ecosystem is constant and absolute. Imagine plants that never stop growing because the sun never stops shining on them. Forests that don't have a single dormant moment in their entire existence. The sheer biological productivity of permanent daylight could dwarf anything Earth's stop-start solar cycle has ever produced. And the night side, the half everyone assumed was a lifeless tomb, turns out to be doing something just as important. Earth loses huge amounts of heat to space every single night, then has to reheat everything all over again each morning. A tidally locked planet's night side does the opposite. It becomes a permanent heat sink, constantly radiating energy away, constantly cold. And that constant cold creates something Earth's chaotic temperature swings can never replicate. A stable global temperature gradient that never changes. So you have one side that never stops producing energy and another side that never stops releasing it. Between those two extremes sits the part of this planet that changes everything you thought you understood. The thin strip of land circling the entire globe caught permanently between the fire and the ice. The Terminator Zone. The line where day meets night. On Earth, that line sweeps around the planet every 24 hours, a temporary, constantly moving boundary you call dawn and dusk. On a tidally locked planet, that line doesn't move at all. It's permanent. Picture standing on solid ground, where the sky in one direction is locked in eternal sunrise, glowing orange and gold without ever fully rising. And the sky in the other direction fades into permanent twilight and stars. That's not a moment you witness for a few minutes at dawn. On this world, that's just Tuesday, forever. And the temperatures here are not extreme at all. They're moderate, stable, caught precisely between the blistering heat of the day side and the brutal cold of the night side. The Terminator zone could sit at almost exactly the temperature range life thrives in. Not too hot for water to boil away, not too cold for it to freeze solid. A permanent, planet-wide ring of mild, livable climate, wrapping completely around the world like a continuous coastline between two oceans of fire and ice. Could this single ring of land outproduce Earth's entire surface combined? Let's build it. Because once you see the full picture, you'll understand why some scientists consider this one of the most exciting possibilities in the search for life beyond our solar system. Imagine standing in the Terminator zone of this world. Above you, the star sits frozen at the horizon, never rising, never setting, just glowing there permanently, casting long golden light across the landscape forever. The temperature is mild, almost spring-like. Every single day, every single year, every single century. There's no need to prepare for winter, because winter, as a concept, has never existed here. There's no harvest season, because in a climate that never changes, plants never stop producing food. Agriculture here isn't seasonal, it's perpetual. Now extend that ring of permanent twilight around the entire circumference of the planet. Thousands of kilometers of stable, livable terrain, wrapping continuously from pole to pole, an unbroken belt of moderate climate circling the whole world. Earth's habitable zones are scattered, fragmented by oceans, deserts, mountain ranges, and ice caps. This world's habitable zone could form a single, continuous, planet-spanning region with no isolated pockets, no fragmented ecosystems cut off from each other by hostile terrain. Inside that belt, ecosystems wouldn't organize themselves by latitude, the way Earth's do, equator near the bottom, poles at the top. They'd organize by distance from the substellar point, the spot on the day side directly facing the star. Closer to that blazing center, life would adapt to intense heat and brilliant, unrelenting light. Organisms with reflective skin or shells built to survive radiation and scorching temperatures. Move outward into the Terminator ring and you'd find the planet's most productive zone, forests that have never experienced a single dormant season, growing without interruption for millions of years, towering higher and denser than anything Earth's stop-start climate could ever produce. Move further still, toward the edge of the night side. And life would shift again, creatures adapted to deep cold and permanent darkness, perhaps bioluminescent, perhaps with senses tuned entirely to something other than sight. And because the Terminator zone never moves, evolution here wouldn't be racing against a changing climate. It would have unlimited time to specialize, to refine, to build complexity layer upon layer without ever being reset by an ice age or a sudden drought. Imagine migratory animals that don't migrate seasonally because there are no seasons, but instead migrate along fixed paths within the Terminator ring, following resources that remain stable for millennia. Imagine flying organisms evolved specifically to ride the permanent thermal winds generated by the temperature difference between the day side and night side. An endless, planet-wide wind system unlike anything Earth has ever produced, because Earth's wind patterns shift with its seasons, while this planet's would be locked in place just like everything else, predictable down to the smallest detail, forever. This is where intelligence becomes almost inevitable rather than a one-time accident. On Earth, intelligent life evolved once, after billions of years, in one narrow branch of one narrow ecosystem, constantly disrupted by climate shifts, mass extinctions, and ice ages that reset evolutionary progress again and again. On a tidally locked world, with a stable climate ring offering uninterrupted resources for hundreds of millions, even billions of years, evolutionary pressure could push multiple lineages toward complexity and cooperation simultaneously, all racing along the same endless ring of habitable land, all competing, adapting, and innovating without the constant biological reset button Earth keeps hitting. And then there's civilization itself. Picture a species that evolves here, in this endless twilight. They wouldn't need calendars built around seasons because there are no seasons to track. They wouldn't need to invent agriculture around planting and harvest windows because their crops never stop growing. They wouldn't lose entire harvests to an unexpected frost or watch empires collapse because the rains didn't come on schedule. Their entire relationship with their environment would be built on one radical concept Earth has never been able to offer its inhabitants: total predictability. And predictability, when you stretch it across millions of years, might be one of the most powerful advantages a civilization could ever have. Now, stretch that civilization around the entire Terminator ring, not contained to one continent like human civilization on Earth. Instead, it spreads continuously along an unbroken belt of livable land circling the whole planet. A planet-wide ring civilization built from countless connected settlements, none of them ever needing to abandon their land because of seasonal famine, none needing to migrate because of encroaching ice or unbearable heat, all existing in the same gentle, golden, permanent twilight for as long as their star burns. Red dwarf stars are the most common in the galaxy and likely to host tidally locked planets. They do not burn out quickly, but for an almost incomprehensibly long time, potentially trillions of years. That dwarfs the lifespan of stars like our sun by a staggering margin. Earth has a few billion years left before it becomes uninhabitable. A tidally locked world around a red dwarf could have hundreds of billions of years of stable, livable conditions. If Earth's window for life is an afternoon, a world like this could have an entire geological age before it properly begins. Could such a planet eventually surpass Earth in every category that matters? More stable climate, more total habitable land when measured by productivity, more continuous evolutionary time, more opportunity for intelligence to emerge not once, but repeatedly. It is almost an unfair comparison. Earth survives because life on it has learned to adapt to chaos. Every species alive today is the descendant of organisms that endured ice ages, mass extinctions, and shifting seasons. That's an extraordinary, hard-won resilience. A tidally locked world would not need that resilience because the chaos that forced it into existence here would barely exist there. Life on such a world could simply grow undisturbed for unimaginable stretches of time. We tend to imagine paradise as another version of Earth with gentle seasons and familiar rhythms. Maybe that instinct is just home bias dressed up as science. Maybe the most successful planet in the galaxy does not look anything like Earth at all. Maybe it is a world locked perfectly in place, one side burning, one side frozen, and between them a single endless ring of golden twilight where the sun never rises because out there it never had to.